This is the Amp Hour Podcast, recorded October 6th, 2014. Episode 219. Caducous, Cyborg, Concerns.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Who is where this week?
I'm in the office talking into a shoe.
In which office? In which state?
In Pasadena at the Supply Frame office, actually.
Oh, there you go.
Yeah. But yeah, I forgot a mic stand, so I happened to get a pair of sneakers in the mail, and now, well, I'll post a picture of my lovely setup.
Go to theamphour.com and you can see it. It's great.
Yeah. So, sometimes you got to MacGyver your situations. That's fine. Whatever. No big deal.
Yeah. It's cool. I can dig it. I almost wasn't here today.
Oh, yeah?
Because my internet was down for like 2.5 days.
Oh, yeah. You've been saying that. What is that? Like
at the lab?
They must be installing the Aussie broadband finally.
Yeah, right.
Yeah. So how do you survive without internet at the lab? That's what I want to know.
Well, I have to use my phone or tablet as a backup. The tablet's got its own 3G card, and I've got a separate plan for that, so I can use that as a backup. But we've talked about this before. It sucks ass. There's just you're so unproductive on a tablet, let alone a phone. Right. There's just so much I can't do on a tablet, or it's just so messy I just don't want to do it. I can't open things in multiple windows. I can't, just stuff like cut and pasting and dragging and, things you take for granted.
Everything's messed up. All your workflows get interrupted,
Yeah, totally.
Well, so I'm working on these websites now, right? And we have to basically make tablet stuff, but then when it really comes down to it, I know that people are going to look at it on tablets, and they're definitely going to check to make sure it can be on tablets, but it's yeah, who's really going to be sitting there in their living room on a tablet unless they have no other option? And that's the reason to do it, is if you don't have another option. But
yeah, exactly.
It's kind of ridiculous.
No, even when I go back home and I'm limited to my notebook. Heck, my 17-inch screen notebook. Right, I'm going. Where's the separate screens? Where's the it's just isn't nearly as nice. So, yep.
First world problems to the max.
Yeah, first world problems. Yeah, that's right. Yeah, because humans need to be productive.
Yeah.
Well, even if we do, we could be on the way out.
Oh, you're going to that? I was going to actually.
I'm going to that. Well, let's save it. Let's save it. Anyway, what my internet problems were? broken fiber down the road. Apparently.
Oh, really? Okay.
Yeah. I don't know if they automatically detect that sort of stuff, or whether or not, they have to wait for someone to complain, and then if they get enough complaints, they go, oh, something might be wrong. And, yeah.
Well, they can, ping devices. I know they can, from, the central server, they can usually...
Well, they can. Whether or not they actively do it and then act upon it is another thing.
Oh, right.
That's what I'm talking about,
Yeah, I'd say you're probably correct that they probably don't.
Right.
Let's do that check-in on all of our customers we love so much.
Yeah, right.
Service first. Yeah.
Oh, goodness.
So I actually I had a similar experiment this week on Friday night. I tried doing layout on a plane. Did you see my write-up on that?
No, I haven't. Do tell. Is this the experiment plane experiment? I thought you meant like a power plane experiment.
Oh, no.
Right.
That would make sense as well. No, so this was a plane experiment where I got on a plane. I was flying out here to LA, and I was like,
how long does that take?
That's like a 4.5-hour flight, so probably
it's
4 hours
flight.
Of usable time, right?
Yep, right.
So something could get done. But,
right.
I always, whenever we talk about, online tools, it always comes down to, what happens when you're not connected? And I'm pretty sure you and I always use the example of what happens if you're on a plane and you want to do it. And so I'm like, well, I should do this. So I started writing it, just basically started a design and started getting into it. And quickly realized that so basically, to cut to the chase, people can read about it. I wrote it all up. I was comparing KiCad or really fill in the blank whatever tool you use that's installed on your local machine, like Altium or Eagle or whatever else, and then comparing against Circuit Maker, which is the new Altium tool we've talked about, and then Upverter. Really, and those three are client side, mixed client, and network, which would be the Circuit Maker, and then mostly network for Upverter, because they actually do have a browser extension you can use. So yeah, just kind of like comparing all those and where you get into trouble. And to cut to the chase, basically all of them, for different reasons than you might think, though, because I don't know how you do design, but basically it's like, even if you have a completely local tool, I personally am so dependent on being able to quickly look up data sheets online.
Oh, of course, yeah. I made this point maybe in the forum or the other week when we were talking about this, is that there's two things you need to do. Basically, if you're doing a schematic and you're designing your product and you're doing the schematic, you need access to the internet anyway. Right. Basically, because as we said, you got to check data sheets. You're so tired there. You got to download 3D models. You got to do all sorts of jazz, right? And stuff.
If you prep properly, you can get away with not doing that. But then that's not really usually a new design
properly. No, exactly. No, that's not how it works. So I was saying one of my suggestions was Altium. At least if you want to allow people to work locally, it has to be on the layout side of things. Because generally, once you download all your parts, you've done your schematic, you push it into your PCB tool and you start your layout, generally you don't need to access the net much when you're actually laying out a board. Right. So,
Yeah, exactly. Yeah, I mean, like if you push a new part in or something like that, but you can probably get away with a lot of stuff. You have to verify your footprints, stuff like that. But that is something too. Like you said, if you're already done with the schematic, you can you could go out and make sure that you have all of the data sheets there already. You can like, I know in KiCad it at least has a field for the data sheet link, but you could just go and download it. Yep. I don't know. Are you do you still download all of them, or is Google your new data sheet
Google's
repository?
my new data sheet repository. I don't keep data sheets on my computer. I keep manuals and things like that, but not like service manuals and stuff. Like I generally keep them because they're often like a bit of a pain in the ass to download. You might have to log into something or do something or other. So I generally keep those local. But no. If it's a data sheet, no, I just don't keep any.
What about like the really big ones where it's like a micro user manual? If
it's absolutely enormous, yes. Like if I'm working on a design and I've got an FPGA data sheet and it's 100 meg because it's got 400 pages in it, then certainly I'm going to keep that locally while I'm working on the project. Definitely.
And I guess we should check in now as well. Do you still print stuff out?
Yes.
Yeah. Well, I think that's
as in data sheets. Oh, yeah,
like
it's
paper.
handy, and paper, and I have it sitting right here. It's hard to beat that. But when you've got a multi-monitor setup, often you don't need to do that.
That's a good point. Yeah, I think my rule lately has been if it has registers, at the very minimum, I'm printing out the registers and like anything A to D's, DACs, that kind of thing. Definitely just I know I'm going to be flipping that stuff anyways. Anything with a register map. Definitely have that in paper next to me, because that's really I think even on a screen, even if you have two screens, it's still not the same to me, because you want to mark it up and stuff like that. So
I don't know. So do you actually have Circuit Maker? Did you use it on the plane?
No, sorry, that was an assumed behavior. So I do not have that. But
so your experience was based on how you used it at the stand.
Yeah, and from talking to them about it, because they cleared up a lot of that stuff too. So asking about creating new parts, I asked them that directly, and they said that unless you have access to because that uses Octopart API in the back end.
Yep,
and I asked, can you make it without having access to Octopart? They said you can't make a new component. I believe, maybe I'm wrong on that, but because they tie them all to the Octopart data,
right?
I don't think you can make a new component, or maybe you can update it later, or maybe they should switch to that if that's the case. But
hang on, coming straight over the teletype here. This is breaking news. Evil Man Scientist Labs just tweeted a response to your shoe photo, and they said, "Whoa, you're making your own ASICs now." And then Nick replied, "You win the internet. Everyone else go home."
Yeah, right.
Yeah, I will pay that. You're making your own ASICs. All right, sorry.
That's amazing.
That's just a little live interjection there.
Oh, I love those guys. That's great.
The show has degenerated into live tweets.
That's
folks.
right. Yeah.
It's all downhill from here.
Yeah.
Oh, goodness.
I think,
what's your conclusion?
So the conclusion is basically you're pretty tied to the internet. I think the one thing I did think I thought I was going to have actual Wi-Fi, like in-flight Wi-Fi, how they do that now. Mm-hmm. I thought that that the plane I was on was going to have that. It actually only had TV, and I think that with that. A lot of local tools you can kind of probably get around it because you could probably download, the smaller data sheets as you need to. You can maybe browse around a little bit. It's not going to be reliable, but and I think same thing with so if you have that, I think you'd probably actually be okay with all three because you could probably get the data sheets. You could probably hook into the Octopart thing on Circuit Maker, and I think even some of the upvoter stuff's low bandwidth enough that you could probably click around, especially if you have the local app. But it's basically you need to prep if you want to do that kind of stuff. So if you are getting on a plane, you need to prep, and that was part of my problem too. Is
you could spend quite a few hours prepping.
Oh, of course.
Right. I mean, so you could argue, well, what's the point? Why don't you just forget doing design on the plane, do something else?
Right, exactly. Read the data sheet
write
or
emails. A book. If you're writing a book, write a book. Or
right.
I don't know.
Well, and I think that is kind of the practical thing. I think that you're right about the layout stuff too. Like if you're doing just layout, that's always like where you're in the zone anyways.
Yeah, of course.
That's good. And if they can all do that, that's great because then it's like. You're just in the zone, and then by the time you look up, you're there.
Yeah.
That's great.
And you don't have to fiddle with the details when you're doing layout. Layout is 80% placement, and then 20% routing. So you just place there. You're shuffling things around,
solving a puzzle all day. It's great.
Yeah, exactly. And you don't have to worry about the fine details. Oh, did I get that footprint right? Well, who cares? I can change it as a fix at the end, right? It's not really going to affect my layout much unless I've completely screwed, like flip the pin out or something dumb like that. But generally that's not going to happen, right? So so you're pretty safe. Laying out, you can probably do 90% of your board layout, just standalone. And then, the rest is a tidy up step. Actually, often I work like that. I don't fuss over the details at the start. I go, no, I just want to solve the routing problem.
Yep.
Look, I've got 5 huge chips on this board. I need to figure out how they go, how to route them on the minimum number of layers, et cetera, et cetera.
Yeah, exactly. You're kind of doing exploratory, kind of just trying to problem solve based on space constraints. Yeah, I totally agree, and I think that kind of stuff is good. Do
you need a real mouse for that? Because I find I need a real mouse for that. I can't use like a trackpad. It's like no.
Oh, definitely. Yeah, I actually. I usually bring like one of those the extendable cord ones, and then you have to have it on your leg, which kind of stinks. Like I actually use my leg because I'm sitting coach, folks. I'm not
right.
Sorry, contextual electronics is not doing that well. So I mean, it's still constrained like that too. So I think what it really proves is that we use the plain example as a
benchmark,
as a test, and it's probably not a valid test. Really, that's what it really comes down to.
Probably not. Okay.
So, your mileage may vary, but I think,
of course,
I think an argument could be made that internet tools are going to get you there 95% of the time. Now, I also wrote in the article that if you're risk averse like I am, that 5% is going to inevitably be the time when you're in production and on a deadline and your internet goes out or something like that's usually the real case, but that's a risk people take, right?
Yeah, if I'm going on a plane, I don't want to do layout on a plane. If I don't have the optimized tool for the job, it just continually pisses me off, so for me, the idea of prepping and then going on the plane and doing it on some freaking little cramped notebook with its, 15 with a tiny little mouse and my arms all at some weird angle because I'm trying to
yourself there, Dave.
Oh yeah, well, no, totally right. I'm trying to do I like tools that work. Tools that that are unoptimized or they just piss me off. Really. So I would rather do something else. I'd rather find there's always something I can do. Always something else I can do apart from that. So, I'm going to end up doing that, I think. Yeah, I can't imagine anything worse unless I absolutely, desperately had to, for some reason.
Right. Well, and that's the kind of thing where you can't really even test that, right? How do you set up a test case?
No, you just have to do it. No, you just get on.
So what I did is I strapped a bomb to my wife, and it's going to go off in 2 days, and I have to fly to meet her, and unless I design a circuit board by then, she's going to explode.
Right.
Bad test,
and we've just been flagged by the NSA, by the automated algorithms.
Bad test.
All we need is the keywords White House and President. And, bingo.
Bad test, Chris.
Oh, goodness. Yep. Anyway.
So, yeah.
Let's not mention how Australia's getting like the US like that now.
Oh, no, we don't need to get into that.
Let's not go there.
Yeah, so... That was my experiment.
So, right, okay. Would you do it again? Would you lay out boards on a plane?
I'm going to try it on the way home, actually. I unfortunately booked a flight. I thought I was flying overnight. I looked again, and it's like, oh, that's 11 a.m. I'm flying out, not 11 p.m.
Oops.
Oh, well.
Yeah, those pesky AM, PM indicators here.
Yeah. So it's not just for the show. I show up, or I book flights at the wrong time as well.
Consistency is key.
That's right.
Yep. Chris Gamble, ever reliable.
That's right. Man.
Oh, goodness. Yeah. Hey, you want to know what I've been doing?
I do. What's new?
Well, what's new will be new today, hopefully, if I get off my ass and finish it, because I couldn't finish it yesterday, is my latest video, which is about the white van speaker scam.
White van speaker? I've never heard of that before.
You haven't heard of the white van speaker scam? Oh, well, no. I'll tell you all about it. Or you can watch my video. No, I'll tell you all about it.
Of course I will.
I think the video's going to be released by the time this thing's released.
Okay.
Anyway, the white van speaker scam, it happens in a lot of countries, and basically what it is you're in a parking, like a shopping centre car park or something like that, right? And someone pulls up beside you in a white van, usually a white van, hence the name, right? The white van speaker scam. They go, Psst, hey, buddy, you want some cheap speakers? And and they look all legitimate. Sometimes the van will have like proper signage on it, and they'll wear uniforms, and if they want to sell the scam a bit more. And of course, the person's intrigued, like 5 out of 10 people will be intrigued. Oh, yeah, give me a look. I can always say no, right? Yeah. So they go out in the van. They got all this, supposedly high-end boutique audio gear in there that you've never heard of, right? They're brand names you've never heard of, okay? But they're eerily familiar because part of the scam is that the names will be very similar to someone or something that you've heard of, right? And I'll give you the example in a minute. And but what the scam is these products aren't empty boxes or whatever. So you do get gear that kind of, sort of works. But it is the cheapest, crappiest heap of shit you can possibly imagine. Stuff that wouldn't even be sold in bloody Walmart. Right, at rock bottom, right? They're so bad. They don't meet safety standards. They don't meet any of their specs or performance standards, right? They're so garbage. And anyway, so they actually sell these. So they flog these things as high-end, designed in Germany and, all that sort of, high-tech, boutique brand. And if you haven't heard of them, you're just not sophisticated enough. That's wow. Right. And they bring out all these fake brochures and hi-fi magazines, right? So they'll whip out this hi-fi magazine. Look at these wonderful review. Look at how fantastic this, and it's all bogus, right? So anyway, they claim, they cost $5,000, and we'll give them to you for $300, and they're
That's
worth
crazy.
about $20, And anyway, they make a huge living out of this. They make a big living.
Confidence scams always are, right?
Confidence scam. Yeah, exactly. It's a white van speaker scam. And by the time you actually get it home, and they come in glossy boxes and everything, by the time you get it home, turn it on, and it works usually, and then you realise, well, that sounds shit, or that projector is garbage, or that, or whatever. Then you realise that you've been had. And it's all too late, and they use fake addresses, and the invoice is fake, and blah blah blah. Anyway, white vans, beware of people in white vans, folks.
There's a new white van though, Dave. It's called Kickstarter.
It's called Kickstarter. Oh boy. Yep. Anyway, I found a couple of these things in the dumpster. Right?
Oh, really? Is that where they came from?
And I had never heard of these things, right? I'd never heard of these brands, and so I posted a photo on Twitter, and everyone came back, that's the white van speaker scam gear. And I went, beauty, I can open them up. So I'm doing teardowns of these
nice.
If you want to see how shit they are inside.
Oh, that's awesome.
Yeah.
Yeah, that's crazy. I mean, honestly, the scams don't change, right? I mean, I say Kickstarter, but I mean crowdfunding in general, right? Ones that are, super janky and promise the moon but don't do much. I don't know, a perpetual magnetic USB charger.
That had to be a piss take. That had to be.
Yeah.
It was so bad, and it got approved.
Yeah.
It got approved by. I can't believe. Well, I can believe it, actually.
It's like people are starting to do penetration testing of the security at Kickstarter.
Right. Yep. And if that's the case, then yes, well done. Yeah. Well done.
Right. You'd think they'd start setting up just plain text filters for certain things.
Right, yes. Tesla, perpetual motion,
perpetual anything, right?
Magnetic energy,
Yeah, energy just in general. How about that?
Just energy in general.
Yeah.
Right? Yeah.
There was an interesting one as well. The Printier, which was another Kickstarter, they wrote about shutting down their production, and they are doing refunds and stuff. I saw
this, so my hat's off to them. Seriously, they admitted that they failed and they couldn't do it, and they're going to refund everyone's money, no questions asked. Fantastic.
Yeah.
Right?
No, yeah.
I mean they're silly for not, right? They just didn't do their homework to begin with, right? And that article we talked about a couple of weeks back about how a $300 printer is impossible. Yeah, you can't do it. Even a $500 is borderline impossible, right? You can't do it. And they got basically caught in the same. In fact, the math is almost identical to what that article pointed out. They needed $1.2 million to make it viable, and they only got $150,000.
Right.
And
exactly.
It's just the economies of scale.
Even if you just take a high level look at it, you look at the just the injection pieces that they had. I mean, they were really nicely designed and everything, and it looks nice. But then it's all about mold costs and everything else. And
the mold costs alone would have eaten up most of their $170,000 they got or something. Because it's a fancy looking product.
When Eric talked about that last week, so they actually did talk. This Printier talked to Dragon, and I was very impressed by that, though. The fact that Dragon pushes that the break even point as the minimum funding goal. So that's
this company went to Dragon. They realized. No, I think it was during the Kickstarter campaign they realized they might be in a bit of trouble. And I think that's what they was. Oh, does it? Okay. Well, anyway, they went to them and they just went, no, sorry, you didn't raise enough money. You can't do this.
Yeah.
Just can't do it.
Yeah.
Yep. So.
It is good that they were able to.
Yep. And they're going to have to eat that loss. I mean, it's not like they partially refund it. Yeah. I mean, you have to be willing to do that in this business. You have to be, if you fail, you have to be willing for it to come out of your pocket. To have it come out of the people's pocket is just shameful, right? And I know that's the risk of Kickstarter. There'll be people out there screaming, but that's what Kickstarter's all about. Raising funds. If you're stupid enough to think that you're going to get all your money back, then
right.
But I kind of understand that sentiment, but sometimes you just have to do the right thing. Otherwise, you can live with a ruined rep, right?
Yeah,
and there are some people who don't care. Oh, I don't care. I don't care. I don't have a reputation, so who cares? But anyway,
you will after that. Yeah.
Right. Oh goodness. Anyway.
Yeah. So speaking of money, did you see this one I posted about the new cost of a fab these days? Obviously, this is my former employer, so it caught my eye.
Yes, it is. $15 billion?
$15 billion for Samsung to build a new fab in its own home country as well. So it's like they already have.
So they're building it in Seoul, are they?
Actually,
south of Seoul.
Yeah,
Suwon
is where the current one is, but they're moving it somewhere else.
Fung Tech they're moving to. Yep.
Yeah.
I'm pronouncing that totally incorrectly.
Right.
All our South Korean listeners are laughing their ass off. Thank you.
Right.
You're welcome.
Yeah. I mean, it's crazy though. It's just like seeing this stuff, and then you look at the scale differences, right? I mean, so we're talking that Printier was what, like 115,000, and that sounds like a lot. And then you go and look at something like this where they're building out new chips, and it's just like.
Well, what does 115,000 buy you in one of these fabs? I've set up production facilities before, and $115,000 buys you, just as a comparison. That's in that entire Printier project. That would buy you, one custom jig, barely. Right? It's like, yeah.
Yeah, manufacturing's expensive, yo.
Yeah, I know. If you want to automate it and do it properly, absolutely.
Right.
It costs a fortune.
Yeah, especially because most of these chip fabs are all like full auto these days too. You set them up.
Oh yeah, totally. Yeah.
They just go. They just
silicon in one out, and tested chips out the other end almost.
Yep.
Yeah.
Exactly.
Who needs humans?
The only reason I was there is when stuff went wrong, and it.
Right. Yeah.
But it was like one person kind of I was like manning a lot of machines, basically. Not a lot. More people did it later, but it's amazing when you get into the groove of it. It's just like it's all robots, man. So it's just robots nonstop. And
it's robots all the way down.
Robots all the way down. Humans need not apply.
Beautiful segue.
Thank you. So so there was this. It wasn't a document. It was like a YouTube video about.
It's a YouTube video.
Yeah, robots, and but my friend sent it to me, and it's just about the coming
apocalypse.
I don't know what. Yeah,
Robot apocalypse.
The economic robotic apocalypse, right? It's probably not going to be. They're not going to kill us and use us for robot fuel, but they are probably going to eat a lot of jobs, and some of the explanations that the guy gives is actually a better comparison than I had heard in the past, right?
Well, this is what he does on this channel. This is CGP Grey.
Yeah,
I'm not sure what that stands for, but anyway, this is basically the style of video he does. explaining things. In a sort of infomercial kind of way,
like Scott
I
Driscoll
guess.
does, Curious Inventor, kind of like similar style to
Right.
Scott. Yeah.
Yep. It's got this really annoying tune in the right-hand channel background. It bugs me.
YouTube critique.
Yes, from a fellow YouTube content producer. I thought, is that my phone doing something weird? And I'm going, no, and I actually hit pause, and sure enough, it was in the bloody embedded in there somewhere. It's just people embed subtle music backgrounds in their videos, in their voiceover videos. Just bugs me. Anyway. Sorry.
Yeah.
Fellow YouTube content producer.
So it's interesting, though, looking at this, and I think we probably talked about this before, because I read there was a book by these two MIT economists, and they write about it, and about very similar things, basically about how not just robotics, but also just automation, right? If you just kind of look at automation as a larger topic,
right.
It really starts to be all encompassing. But we even think as electronics designers, right? That nothing will ever take our jobs there. And it's like, well, wait a second, it already kind of has. It's just it's not as active, right?
Right.
So I've talked about like in the analog side of things, it's not like someone's coming in and using an auto router to put together circuits. What's actually happening is on the supply side, it's that chip companies want to make more money and grab more of the market, so they basically just start integrating more functions on silicon. That's the side. That's actually the automation side that actually affects more electronics designers these days. Same thing for micros,
because
right?
Any schmick can come along. Any schmuck can come along and follow the application note circuit, use Eagle to lay out a board, and bingo, they've got some advanced functionality doing bloody DSP and HDMI and all sorts of jazz, and they can sort of hack it together and make it work.
Right.
So,
exactly.
Whereas 5-10 years ago, that was rocket science.
Right. And if you're used to like someone like you who always did like high speed interconnects, right, and like needing to have really good impedance controlled boards and stuff like that. Well, when that stuff moves on silicon because it's more efficient to do so,
exactly.
You need fewer designers, and you can have schmucks like me that like it's just then the hard
you
part
can
just
do
becomes
high speed USB and HDMI on a 2-layer board.
Yeah,
for goodness sake, right? And make it work if you keep the connector near enough to the bloody chip. That's all you need.
And that's in the app note, and then you have, and then also with open source hardware as well. I mean, these are all benefits as well. That's the weird thing, right?
No, of course.
It's we're like frogs in a pot of boiling water or rapidly warming water. It's like no one's going to complain about it because it's beneficial, right? You can make products faster, and you can do more interesting things. I mean, but there is that weird economic component to it of like, oh crap, well, it used to take 10 people to design this thing and now it takes one, and it's way cheaper to do so. That's crazy.
And look, it's one of these doom and gloom videos, right? That how all our jobs are absolutely redundant now and robots have already taken over, we just don't know it yet, blah, 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 blah. Yeah. And, well, you can argue they're not half wrong, but it's not as apocalyptic as they make out. It's just crazy.
Yeah. I'm trying to find the name of this book as well that I was reading, because it actually is quite good. What is it called? The Second Machine Age. Oh, yeah, that's the one. The Second Machine Age. That's the one I've mentioned on the show before. But, basically between this video and the book and everything else I see about it, what it ultimately brings me to, like over and over again, the only thing that I really start to come to a conclusion of is there's two options in the future. One is have a hard time finding a job, or two is own the automation systems. Like that is it. So people listening, if you're looking for a career change or if you're looking to become wealthy in the future, like that it's gonna cause a greater divide, I think, as well. I mean, obviously there's a very large economic argument here as well, and but if you want to go into the if you want to be in charge, though, basically be the one who makes the automation systems. That's what it comes down to. And when I say automation, I don't mean home automation. I mean it could be software, it could be software and hardware, it could be hardware alone like robots, but anything that makes things easier, right? It could be industrial automation, right? This is like the jigs you talked about in manufacturing. That is technically automation, right? I mean,
somebody has to build and design the jigs, and robots aren't going to do that, so.
Well, but
no,
basically,
they're not.
No, I know you're
right. Don't buy into the hype.
I'm not going to say that, Dave. But what I'm saying is the same kind of thing's going to happen, right? You could move it forward in the design cycle. You could move to the design for test or design for manufacturing, where maybe you move it all to be on a JTAG chain, right? So maybe you don't need as many test points, right? You start to move in that direction, or everything moves on silicon. It gets tested at the silicon level. That's going to be like, I totally agree that you're not going to have these super intricate tasks that those are not going to go away, but they're going to get shifted forward in the design process. That's what electronics people are going to see, I think.
Well, yeah, but then you move into the physical handling side of things. You still have to connect up your test points and and your jigs and do everything, the manual handling of the boards and how that optimizes and how that flows through through your production process and all that sort of jazz, you know?
Yeah. Well, I mean, maybe, yeah, but like, okay, how about another example? Like, I'm not, like you said, I'm not trying to be all doom and gloom here, but actually there are interesting examples here too.
I think he is,
right?
folks.
Like how, how about the Intel Edison? We talked about that one before, but like that, basically, that's basically designed to be a module that gets designed into a final product, right, from Intel. It's very fancy. And obviously
but it's not going to be.
I know, right? But they're not the only one. Obviously, there's a lot of modules out there. There's been for a long time. But, like, basically...
The laws of economics aren't going to change. Can we agree on that?
I can agree on that. Yes, I totally agree on that.
Thank you. All right.
But what I'm saying is the changes we're going to see as electronics designers is going to be the shift towards, modules and then eventually getting it all on silicon. That's the shift that's going to affect us the most, I think. It's not going to...
Yeah, but there's nothing that's not already here.
Right, you're right. Yeah, but you said it's an economic argument, and I'm agreeing about that basically. Right? If you say you're a company and you've got 10 engineers, hardware, software, firmware, whatever. Right? If you can now move from the mix being 3-3-3, right? Because I saw this at my last job actually.
Right.
It used to be, out of those 10 engineers, it used to be 5 or 6 of them were hardware engineers, right? And you had
now you get away with 1 or 2
and one software, and then the shift became 1 hardware engineer, 4 firmware people, and 6 and 5 software, right? And it just shifts towards software because it's you can change it over time. You can update the firmware, but then you can also you can write more interesting stuff on top of the software, and it's just like that is more economical, I think. I mean, maybe even to the point where some companies are going to go and just drop the hardware guy entirely and just go buy off-the-shelf hardware, right? So,
right. Now, this brings up, we can actually get figures from a company that does this sort of thing. Sparkfun have published a nice little infographic here, as much as I hate infographics, this one works quite well, showing how much time their people spend on what particular parts of getting a product to market.
Yep. And so
guess what the biggest one is? It's a big rotating pie chart, right?
Yeah. This is from Mike, who's been on the show. Mike has been on the show, and so the rest of the engineering team has as well. So
right. So this is a nice little pie chart showing the breakdown of where all their engineers and product developers spend their time.
Yeah.
And we'll post this in. We'll post this. So go over to theamphour.com, check it out, and guess where they spend their most time. Come on, at home, you have to.
I was going to say, I'm looking at it. So
I know. So we'll give people 5, 4, 3, 2, 1. Documentation. Yeah. 20% of their time is the biggest one. Writing libraries is 15%.
Yep. And just like other stuff is 20%, right? Like
where's 20%?
Well,
stuff.
It's meetings is 10 and miscellaneous 10, so...
No, miscellaneous 10, right. But revising and reworking prototypes is 10%, board design is 2.5%, breadboarding is 2.5%, firmware is only 5%. A lot of people think, it's all in the firmware. No, 5% of their time. Writing libraries takes 3 times the amount of effort as firmware. And that's not surprising, because once you're writing libraries is hard, but once you've done it, the firmware becomes easy. Right.
So, and that's the point of doing it, is you get reuse and you start
of course.
variations
you get
of
gains.
Yeah.
Once you've written the library, you get those gains in your firmware. So that's why. And then example code, 5%, learning 5%, making projects 10%, exploring 5%. So documentation is the biggest part of it.
Right, and this is why we run out of things to talk about, folks, because hardware's only, 15% there?
Like total or something. Yeah, that's right.
Which is the Kickstarter percentage, Dave? That's what,
Right.
We should respond with our own. Or if anyone wants to turn the Amp Hour Bingo into a revolving wheel of this thing we're saying. And a lot of it would be not fun as well. Yeah.
Goodness.
Yeah, this is really great though. I mean, and it is true. Like I think the thing that actually isn't on here. I mean, it's probably rolled in the other ones, but like sourcing, right? So sourcing parts, maybe that's less so for them because they have they have a library already set up, or they have like a standard part library they're doing. But that at least for me, like that, like finding new parts, sourcing new parts,
right? Yep.
Like actually going out and buying them, opening, packaging, organizing all that crap. That, especially for prototype type stuff, that's a huge part.
Well, you can argue that. Well, yeah, but you can argue that Sparkfun don't really do finished products as such. They do more development boards and stuff, which are easier than, or they're much less complex and more specific than a generic product. Than actually designing a finished product.
Oh, maybe. I think a lot of the same stuff is. I mean, like, what is it? Plastic on top, and I don't know. A lot of that stuff. Like, if it's just breakup boards, that's one thing. But I think development boards definitely has, breakup or development board.
Oh yeah, but it does. But it's not
components.
The same as a finished product where you're aiming to, okay, we're going to make 10,000 of these. They don't care. They know that they're only.
They have to make even more than a lot of people out there do, because they actually produce this stuff. So I think though that they have sourcing people as well, which can help. It could be. Yep. It can be crappy as well. I mean, having that divide between engineering and sourcing can be miserable as well. So, yeah, I don't know.
Anyway, that's an interesting little pie chart.
Yeah.
So, but yeah, I think it's skewed towards that. Well, it's obviously skewed towards their style of what products, in quote marks, that they actually produce.
Yes.
Whereas if you're working on like a real consumer level product, it will be different,
Yeah.
So, yep.
Yeah, if I had to quickly break down my past stuff, it's like 30% corporate garbage, 30% shopping and or meeting with vendors, 10% designing and testing and retesting hardware, and then what I leave out, like 20, I don't know, 20% sitting in meetings. I guess that's corporate garbage as well.
Yep. I'm glad I don't have to sit in meetings anymore. Jesus.
You got one per week, man. Terrible.
Oh, yeah, I do. This, yeah.
Yeah. The best meeting you've ever been in. So speaking of sourcing parts, though...
Well, hang on. I didn't tell. Hang on. I didn't tell you about my solution to the coming robot apocalypse.
Oh, yeah? I want to hear this.
What I'm doing to avoid that.
Okay.
I've simply moved into the entertainment business. No robot's going to compete in there.
I don't know, man. They did talk about...
No.
In that video, they talked about robots writing articles, not necessarily entertaining articles.
Yeah, and they're shit, and nobody wants to read them.
Well, yeah, you're right. I mean, but they cover the creative side of things, though, too. I mean, like, I agree that, like, right now it's going to be whatever, but...
No, I'm sorry. They're still going to be full of shit. No.
Right now, I mean, that's always what it is, Dave.
That's always the fear mongering of this. Yeah, I'm drawing a line in the sand.
Yeah,
they're not going to be bloody creative. They're not going to be creative enough. I don't. You can always go, oh yeah, in the future, and you can extrapolate things, and it's like, no, I'm sorry. There's huge thresholds there that have to be overcome before they become so intelligent that they can actually not only do art, for example, or do comedy, but explain why they're doing it and how and all that sort of... It's just, no. I'm sorry. Humans are always going to win.
Okay.
I will predict, not in my lifetime. Not in my lifetime.
Right, because the robots are going to take you out, man. Get rid of the influencers first.
Actually, I will even predict, not in Sagan's lifetime, will... so I'm talking like the next,
100 years.
100 years, right? I'm talking, let's round it up to the next 100 years.
Yeah.
Yep, well, let's round it up to the next 100 years then, that robots will not be as
I don't know, man.
creative
would
like
pull
this.
Out a exponential chart right now, even though he's a crazy nut job.
Well, I'll shove it right back up his behind.
He's a little crazy.
Because I think he's wrong. Yeah,
I think he's pretty spot on with the exponential growth side of things. Like
it doesn't make him right on all things.
No, of course not. But I think that's correct. I think that our ability to see into the future is so limited by predictions of linear growth.
Yeah.
But then again, I really don't know about the creative side of things. Yeah. And I'll tell you this. I don't want a robotic Dave out there.
Right.
This one's bad enough, folks.
Yeah, exactly. Some people say I am a Dave bot. You know, I just keep coming out with the same shit every time.
Believe me, they'll never figure out how to program an Aussie accent into a robot.
Look, take the classic example of the game of chess, right? Okay. That's always been the benchmark intelligent test of when computers would get more smarter than humans, right? Could they beat a human at chess? And currently, yeah, they're kind of sort of able to beat a human at chess.
No. Right? They beat humans every single time. They covered this in that second machine age as well. Every single time. No, believe me, every single time. But the interesting
last
thing
I checked,
they talked
it wasn't.
About, no, yeah,
it wasn't that good.
Kasparov beat Deep Blue once, and then right after that, he.
No, but I've read thoroughly on the Kasparov incident, right? And it turns out he just lost. He basically gave up. He could have easily drawn that match and taken the championship, right? And not lost. But he simply gave up because he was so stunned that it made this move that, you know, he just went, that's bullshit, they're cheating, you know, and he just, there was a human factor, there was a psychology factor involved in there. Okay. And I'm saying, well, that's because some people say that's part of chess, right?
I was going to say, if you get your opponent to quit, you win.
No, but anyway, he was not thoroughly beat.
I'll reference
what the point was.
Ender's Game right here, you know?
Okay, right.
I won the game.
He was not thoroughly beat, is the takeaway from that. He could have won that.
So that aside, every time since, the computer keeps winning. So
right. Anyway,
but the point is,
I haven't finished my point.
Okay.
Right. The point is, the computer might win, but the computer cannot explain how it wins. The computer cannot. It still does it by brute force, right?
Yeah, correct.
Still does it by brute force. Okay, right. And that's the tell, right? That's the thing that tells me that all this prediction about, in 15, 20 years, computers will be smarter than humans, it's bullshit, right? And they'll be creative, and they'll do art, and they'll do comedy, and they'll do music. No, bullshit.
Actually, this proves my point as well, because the second machine age talks about this, right? So they say humans always lose to machines. However, humans plus a machine assistant will always beat the best machine in the world. Basically, the creativity of a human plus that. And so that actually proves my point of
because they don't have creativity.
Right.
That's what I'm getting at.
Whoever owns the automation and the robotics side of things, right? If there's human intelligence behind it, they are always going to win. So that's why my point is proven.
Yeah, totally.
Yeah.
Yeah.
And you'll just find efficiencies. It's an economic argument. You'll always find efficiencies if you have this automation. Like if you compare that versus like having to hire 100 people to do something. You know, if you have a robot, you're always going to win with the robot because of cost.
Right.
So.
Yep. And then cost aside, humans can always do an infinite more than robots. Yeah, the classic case is going to Mars, right? Why send humans to Mars? Why send robots instead of humans, right? Humans can do 1,000 times more in the same time that a robot can do. Right? Because they're there, they're able to go, whoa, what's that? Whoa, look at that shit. Let's do that. You know, they're able to think on the spot. They're creative creatures. They're, creative, inquisitive. They're, all the stuff that makes us human.
It's not about reproducing. I always say it's not about reproducing information. It's about synthesizing information, right? That's ultimately what a human's good at or better at than computers, right? So
and understanding new things that they haven't
I totally agree.
encountered before. Whereas computers, unless they can have algorithms to learn that, it's just no.
I think
so. You've got to know what the problem is.
Is that we mistake regular tasks as needing synthesis of information, whereas many more than we actually perceive are just repetitive type things.
Yes.
Right?
Oh, yeah, totally. Like a lot of PCB layout is repetitive.
Yeah, right, exactly.
I'll happily, admit that. And that's why a good PCB designer will use an auto router very selectively it's like that combination. It requires the human plus the auto router.
I need a new
Right?
T-shirt. I need a new T-shirt. Never trust the auto router with
Trust the
everything. That'll be the next ref. Yeah.
Yep.
Speaking of, I have a new T-shirt out, Dave. Did you see my new T-shirt?
I have seen your new T-shirt.
Yes.
I don't know. I have the odd question about that.
Yeah. What about?
It's you're talking DC only. I mean there's a bit of fuzziness there but you do show a DC battery on it.
Yes,
so granted it is that case, but what about the the instantaneous case? It takes time for the electrons to get across, so when you flick that switch, it's like, so you're not talking.
Should I have put it in the bottom, like assume steady state? Should I cancel the
assume
T-spring?
steady state condition? Yeah, exactly. Assuming steady state condition. Yeah.
Oh my god. Okay. Maybe I can add that to the back. I don't know. I don't want to cancel it now, but if
it's getting a bit geeky now. Yeah.
If the Teespring, now it's going to be geeky, Dave.
Right. Well.
If the campaign fails, though, I'll definitely revise it with that.
Right, because that will be the sole reason it fails, right?
Right. Not because people
everyone
don't
goes,
need
that's just stupid.
People don't need another nerdy T-shirt, but yeah.
Oh goodness, yeah.
Yeah.
All the pedants coming out of the woodwork.
Yeah.
Yep.
So what I was mentioning before, though, with layout stuff, Octopart recently they paired up with Seed Studio. Remember I talked about the open parts library a while back?
Right. Yep.
So they paired up with them and a couple others, I think Adafruit and a few other open hardware companies and stuff like that. But basically, trying to standardize this idea of a regular set of components and then having a couple comparisons for each one. So looks good. I mean, I think that's a great idea, especially if you're moving into. Oh, I know Chris from Worthington as well, so another assembly house there. It's a cool idea,
and that's what Altium's moving into too, because they're using the Octopart back end.
That's
so
right.
they'll ultimately, I guess, tie into all that, or maybe they're doing their own thing. I'm not.
Proto
sure.
Exchange, Tindy, Tempo Automation, RF Factory, Make Simply, Dragon, Electric Imp, Highway 1. Ooh, speaking of Electric Imp, I'm actually having this should be out in time, but Brandon, who's on our show, he's going to be. I'm going to be there's a meetup out in San Francisco. So if there's any San Francisco listeners, Brandon will be giving a talk about hacking sub-gigahertz RF and then tying it into Electric Imp. And then there will also be a talk on reverse engineering file formats for CAD programs. So that's going to be fun.
Awesome.
Yeah, I'm excited about that one. So and Brandon too. So
excellent.
Yeah,
sounds good.
So yeah, the Common Parts Library. I think this is going to be really cool. So definitely good stuff. They should keep it up. I think. Yeah. There's like 150 right now or 200. I'm not sure how many exact parts right now, but like we said last time we talked about this, there's a good number of things on here. You could really make a lot of different things with this, basically. So very cool stuff.
Totally. Yeah, I like it.
Yeah. What else? What else should we talk about?
We've got.
We got time.
Chip of the week.
Oh yeah, which one?
The Max 10.
Max 10. Oh, yeah.
The new FPGA.
So
which I was confused, right? Yeah, I've looked at it, right? I was confused because I go, well, Max, that's a CPLD, isn't it?
Yeah, exactly.
Like, I was like, they've called an FPGA. Well, apparently they've always used it, for a long time, they've used the FPGA fabric inside, but still my old brain thinks, associates Max, the Altera Max series with the PLD.
And stuff like that.
Yeah, exactly. Yeah. It still associates that with a PLD. So anyway, they've decided to call their new low-cost one the Max 10 instead of calling it the Cyclone 20 or something. It's the...
Right, yeah.
Yeah.
Well, and you will be sad to know that I saw Mike Harrison tweet about this, Mike's Electric stuff. He said there are not any low-scale
Yes, I've seen that.
So.
Yep. No, of course there aren't.
Womp.
They just don't give a shit. They don't give a shit. I've been asking for 15 years. They don't care.
It is
Every
a shame
time I
too,
ask them, they tell me the same thing.
Well, they talk about having like an Arduino compatible like dev board and stuff like that too, and it's just like, especially if this is going to be low end, you'd think why not go really low end? Why not like, I don't know. I guess it's just how they position
Well,
themselves.
there's no market. They have it shows how pathetically insignificant this Arduino market is to these chip manufacturers. It's nothing. It's chump change.
Yeah, I know that. I didn't mean
they're just including.
I just meant like the friendlier package type. Just as a signal.
That's what I'm talking about, right? The friendlier. There is no market according to them. There is no market for it. This is all their reason. It's chump change market, and they simply are not interested. Yet they'll happily throw on this Arduino bloody shield footprint, right? Just to enter the wank market. Right?
Well, I'm not even talking about that, though. I'm just talking about like getting it into 2-layer boards, right? That's all I really
I know,
think about.
I know, but they claim there's no market for it.
I guess maybe that is a signal of like a lower cost. Like they don't want to like be perceived as like cheap stuff, or I don't know. But
no, they probably don't want to have the race to the bottom, right?
Yeah,
because
right.
Then if it's only if it's a 20-pin quad flat, huge pitch quad flat pack, then people are gonna want it for $1, right? They're not going to pay $10 for it because I could buy a micro for a couple of bucks, right? And so they're just not chasing that low end. It doesn't.
Yeah.
Anyway.
Yeah.
I know.
Are you a Xilinx guy still, or are you
I'll use
Altera?
whatever is the best fit for the purpose.
Gotcha. Usually it comes down to tool chains for most people. That's what I've seen.
Yeah, it does. But I've used both. It makes no difference either way for me.
Both. There's only two.
Well,
right?
both. I've used three. No, well, there's 3 or 4 of them.
Yeah, there's 4.
So,
that's the answer, Dave. There's 4.
Yeah, exactly.
There might be another startup at some point.
But there's 2 big players who own 90% of the market. The others fight over the 5% each.
Yep.
Crumbs, right? So, Anyway, the Max 10, blah, blah, blah. It's got a 12-bit ADC in it that probably only has 8 effective bits, blah, 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 which is, handy. That's fine. It supports DDR3, blah, blah, blah. It's got an internal RC oscillator, which is kind of handy if you just don't give a toss about, it's around about 20 megahertz. Doesn't have to be exactly. It's good enough. Right, which is great, right? There's one less bomb item you have to worry about.
You ever see that movie, Billy Madison? I imagine the chip being like that, where like the drunk guy wakes up, it's actually Norm Macdonald, and they go, "What day is it? October?" Right. It'd be like using an RC clock as a real-time clock would be like that,
Right. Okay. Oh, you can get within a couple of percent.
I know, but I'm just saying that's what I think of, right? Like that's.
You're right. Yeah.
October.
It's good. Yeah. Right. Anyway.
So I was at the speaking of chips, I was at the Hackaday 10th party this weekend rather, and there was one talk by Lost, the guy that does the badge for DEF CON. That was really cool and definitely worth watching. But the other guy that talked, actually the other guy that works on the badge, was talking about Propeller stuff, and I realized that we actually never mentioned a pretty interesting thing that kind of involves FPGAs as well. A while back, Propeller or Parallax, they actually open sourced their entire design, and we didn't mention that. So
I'm sure we did.
I know we didn't because someone yelled at me.
Oh, right. Well, I mentioned it on Twitter.
Yeah. I mean, I saw it there too.
I'm pretty sure I did. Or somebody yelled at me on Twitter because I forgot it, and then I yelled
that's
back.
what it was.
Okay.
Yeah. So it's really interesting too. Like that you don't really see that. I know. So they said open sourced as well. I know that you could get an ARM 0 core. I'm not sure if it was actually. It might have been encrypted though. But I remember you could get that and put that on an FPGA. And there's a couple others you can get out there, that. But I don't know if any of them are actually like open source.
Right. So has anyone now taken that design and put it onto an FPGA?
Well, I bet they did.
Oh, right. Okay. Well.
But yeah, I don't know though. And it's kind of weird too because So I had never really looked at the logic blocks and all the stuff that's actually internal to the chip before.
It's a multi-processor chip. It can do multiple things, and it's kind of pointless. It's like, why, if you go into an FPGA, why put a soft core into it, even if it and it's a multi-core soft core? It's like, just buy the chip, just use the damn chip. Why put it on an FPGA unless you have to integrate other stuff with it? It's like, I don't know. You're just making life hard for yourself.
So the times that I've used a couple of soft cores before, and really it's like, because you have firmware resources, you're doing something in logic, and you don't want to put a separate micro and have the memory interface and everything else. But even that's it's always been really messy.
But it's I know it gets messy. That's what I'm talking about.
Yeah, but
why make it? I'd rather have separate tasks and put the effort into the PCB layout to actually do that than to put it into the FPGA.
Well, the other thing though, too, is sometimes you could, if you were in, I'm talking out my ass, I actually don't know. But the theory, I think, is that you could, if you could save money on a micro, these days it's so cheap that it's just like, just throw something on there.
No,
but
exactly.
I think a lot.
Because FPGAs are not cheap, right? To get them a decent amount of logic core and everything you want, they are not cheap.
Right.
So you've got to have a good reason to use them. And they're complex to use. The tools are complex, and so you've got to have either it's got to be like a flexibility reason, a multi-processing, hardware. You've got 20 serial interfaces.
That's the example I was thinking of. And when you really, really need a lot of customized, you can't find it. So
yeah, that's right. Or you need 20 different micros to do the job. Okay, well you move to an FPGA. Fine.
Yeah. There's probably better ways to do it if you need 10, 20 micros, though. So, I mean, it's still interesting, though. I mean, I think the fact that Parallax did that, that they released it, and the reason they did is actually they're working on a second version of it. Now, what I didn't realize is that they have their own programming language. You can use C, but, there's also... Spin is like the programming language.
Yeah, that's right. Yeah. It's a high-level thing. Yep.
You kind of got to drink the Kool-Aid and jump into their
their
way of thinking. Yep. But I think that there's benefits to that. Thinking about coprocessors and stuff like that for robotics. I know a lot of people talk about Parallax stuff for robotics is good. So
it's probably the lab view of the microcontroller world, perhaps.
The lab view? What do you mean? Because it's
because it's own unique language and it's it's not. Well, I think it's not far off that, isn't it, or something? I don't know. Anyway, I haven't used it.
It looks like. I mean, Johnny Mack who was talking about the Parallax stuff. It looks like Python-ish,
Okay, right.
But kind of like shorter commands. So,
right.
Yeah, it was very interesting. All the talks that day were quite interesting. So, a lot of those are going online. That's fun.
I think that's probably the best thing they could have done is open sourced that. It will ensure the survival of it.
Yeah, well, and plus it's just interesting for users to be able to dig in. Because otherwise they've risked going out of business. You can actually go and look at the code then, and maybe that piques some interest into getting into chip design, that kind of thing. So, yeah, it's... Or
if it's scalable, because this is already I think it's like an 8-core processor or something, this Parallax thing. If you can sort of then, if they've done it modular so that you can expand that when you put it into an FPGA. You need 20 cores?
Yeah, they mentioned that.
Sweet.
The cogs.
The cogs they call them. Yeah.
Yeah, you can expand
you can just expand them.
Yep.
See, now that's clever.
See, the only thing I don't get about that though is that I thought that they have interesting analog peripherals on the end of the actual. Maybe it's the new one. Maybe that's what I was thinking of. But they had interesting non-standard logic blocks. Yeah,
which you can't get when you translate it to an FPGA.
Yeah, so if you have an analog pin there, you can't do that on most FPGAs. No, so that's right. Obviously, I don't know what I'm talking about here, but
but it's right. It's just the processor side of things. Yeah. It's not the analog blocks. Yep.
Yeah. So it's cool. I've come to the point where it's like, all right, I'll go look at that more.
Right.
Yeah.
Yep.
So.
No, if I wanted to do parallel processing, I would certainly check it out.
Yeah.
Otherwise, it's meh, I might as well stick to, if I'm just doing my regular micro single task thing, I'm just going to stick with a little
Oh,
micro.
yeah, simple, yeah.
Yeah, of course.
Yeah, are you, you use picks on your stuff a lot? What did you use?
I use both.
Yeah.
Picks, Atmels. I'm
Yeah.
not fussy. Yep. They're the two I mainly use.
Okay.
Yeah.
I've been looking at a new platform, trying to just try out new stuff, and I've never used a pick before, so I'm interested in it, but
right.
not really sure where to go with that stuff. You know what I mean? Like, it's like, well,
yeah.
I'm kind of choosing just because I want to try something different. It's not necessarily like I'm being forced into it.
Right. Okay. Right.
And
I'll usually
Yeah.
pick based on my requirements, right? I go, I need to meet this price point and I need these features, and, pick
okay.
just have a larger range
Yeah.
of chips that suit your thing than the Atmels, right? The Atmels are sort of like, everyone uses an AT 8 mega or something, right? To
Yeah,
do
the 18
everything.
mega 328, yeah.
Yeah, right. Or something like that, right? So whereas microchip have 10 times more range of chips to
Right.
suit a
I see, I
specific
see.
niche thing, and that has its good and its bad points in terms
Yeah.
of longevity and availability and all that sort of jazz. But yeah, anyway.
Yeah, well, and that's another thing someone mentioned at this thing over the weekend is MP Lab is like I think that's the online thing or something like that, or there's like the development tools or something like
No,
that.
it's totally changed since I've last used it.
Okay.
A lot of people complain about it now.
Yeah.
I haven't used it since the complaints have come out.
Yeah. Yeah, I don't know. And like there's other stuff out there too, like the embed. Like that's another one where it's like I think that's actually online because we were talking about like the online CAD stuff, but then there's all these online compilers and IDEs and stuff like that.
Yep.
And it's interesting to me, but again, it's like I don't really I'm used to like the download the IDE, struggle with it
so
for
am
a
I.
long time, and
that's right. Install it and then
6
figure out how all the
gigabytes
projects
of
work and all that.
install.
Yeah, that's right.
Yeah.
Yep.
And
Same here.
So it's just kind of like getting older. That sounds stupid. I'm not that old,
exactly.
but just kind of as new stuff pops up and
Well, see,
forcing
that's the
myself
thing.
to try it.
Well, like if I had to use a new device, that would be compelling for me. If something had just a browser-based compiler and it just worked or something, I might give it a go.
Just to try out the
because
browser-based, you mean?
Well, no, just because I wanted to use that particular chip because it had the features of the price or whatever I wanted. And then if I knew it had, some complex compiler chain that I had to download and struggle with to get working, then I'm going to groan and go, I don't think so. But if it's got something really dumbass, user-friendly, browser-based compiler or something that just works, then I'm going to go, hey, yeah, I'll use that. Because I'm not betting the farm. I just want to do a project. I do it project from project, right?
Yeah,
project to
right,
project, and I don't care if I
and your long-term risk is not there as much either, right? You don't have to lock down your tool chain. Yeah, because I was thinking about that.
I'm not committing my entire company to change to this architecture.
Right. Yeah, that definitely does change stuff. And like when I think about like trying out new chips, like that's kind of what's always guided me in the past. It's like, okay, well, I don't really have a choice, unless you're doing it on your own.
Right.
It's like, okay, well, you're using microchip parts because everybody does it at your company or Freescale or whatever else,
Yep, that's right.
And so I don't know. Same kind of thing for me. I'll have to try that out and see. I guess the benefit of that and what they're probably banking on is that like, people like us or people that are coming into the industry as well, like if you don't know any better, if you don't have these prior expectations, like of course you just kind of roll with it, and if it works, it works. Cool, no big deal, right? If it doesn't work, we can play the amp hour.
At the end of the day, that's all I care about. Does it work? Did it cause me any grief? Is it going to cause me any grief?
Right.
Yes,
well,
no.
And usually, the other thing for that too is like we won't know until later. You don't know until you try it and really get burned as you go to production. But I guess we'd have to depend on the kindness of strangers to let us know about that beforehand.
Yeah, exactly.
Yeah. There was a bunch of stuff there was that ARM conference last week as well. So there's a bunch of new ARM stuff that got announced. But this Atmel one looks interesting as well. Like it's basically like a little embed, basically. So I think it can do the online stuff, but then it's got a radio on board and interesting things, I guess. I don't know. It says IoT, so I'm like, meh. But I mean, like I said, I am interested in trying some of these online tools, and if I'm going to give the online CAD tools a try, I might as well try the online code tools.
Yep.
I definitely need more help with one than the other. So, yeah.
There you go. Yeah, that Atmel's an Internet of Things development platform. Yeah, you can see me doing the whoop-de-doo hand gesture right about now, twirling it around.
Yep, exactly.
Goodness gracious. Can we stop talking about that shit now?
Sure.
Yeah.
Anything else this week? We're actually kind of...
No, we're over time, dude. 10 minutes over time.
Yep.
I got things to do.
Yeah, sure, yeah. I have to go eat dinner. Actually, this we should have brought up earlier, but there was a good article earlier this week, kind of like on the same vein as the 3D printer side of things, but basically talking about the differences. I think it was actually from Bolt. The Bolt guys wrote this, but basically how you can't be like Apple for manufacturing, and like the same assumptions do not apply to everyone. So that's
right.
That's definitely worth the read as well. As people are getting into manufacturing things, if they haven't already, it's good to have those things in mind. So
right.
I think that's it from the list. Hopefully I didn't skip
I think we're
anything.
done.
Yeah.
I'm going to go.
Okay.
Shoot some more video, and hopefully my camera doesn't screw up and not record the footage. That pissed me off.
Time to build your own camera, man.
Oh, man. Unbelievable.
All right, cool.
Anyway, see ya.
Catch you next week.
Bye.